So, as just been said, I do computer science. So what I am going to talk today is about how to build responsible artificial intelligence, so algorithms that are free to human bias and discrimination. And I am going to focus more on the topic of gender, given the venue, but this is something that expands across other different characteristics. So basically, we have to admit that gender discrimination persists. We have data, for example, here from the UK that in the last 10 years there has been almost no progress in improving inequality. We have data related to the gender pay gap, responsibilities for childcare that most of the time are supported by women, and we have a very small representation of women in the key positions in companies, etc. And we have just a few examples from this example about the policy of dressing codes in some companies being discriminatory, or even the fact that the members of the parliament are also affected by the gender pay gap. So we have to admit that we live in that society. And another thing or current trend in our society is that nowadays more and more decisions are delegated or at least informed by algorithms, by programs. From the jobs where we apply for, to the products we buy, or to the needs we read, or even the people we date, most of the times we are making that decision based on the output of an algorithm. And these algorithms have some particular characteristic. They improve or learn automatically through experience. So they get exposed to some data and they try to make better and better decisions. This is called machine learning. So there are two different trends of algorithms. Algorithms that are going to try to find patterns in a given data set. For example, identify the associations between the characteristics of candidates for a job and the hiring decision that was made. Or we have algorithms that are going to predict that decision. So basically, they are going to try to find a rule to match from a given input, for example, in this case, the characteristics of a job applicant, to the output, the desired decision, to hire or not that applicant. And the algorithms have many benefits. They are cheaper. Once you have trained one algorithm, you can replicate that anywhere. And they are also perceived by us as faultless, in the same that they don't have the same problems that we humans have. For example, they don't get tired. They can repeat the same process again and again consistently. And we also tend to think that the algorithms, they don't have personal prejudices. They are free from bias. And because of these reasons, and also due to the fact that the general population don't understand the algorithms, and even computer scientists, most of the times the algorithms are so complex that even if we can inspect the code, we cannot understand what is going on. So we don't have really an easy way to scrutinize them. We don't scrutinize the decisions that they made, as we probably will do with the human counterparts. But we need to take into account that the algorithms are not free from discrimination. The algorithms are learning from some data. If that data represents discriminative decisions, they are going to learn that. So they are very likely to inherit prejudices of the programmers, because at the end they are done by people that have their own mindset. Previous decisions, the users, because some algorithms are trained as they are used, so basically they will consider what has been done by the users to improve, or even the society. It might be the case that, for example, the fact that we consider some qualification in some particular algorithm to decide which candidates to hire is making that sectors of the population that cannot access that qualification are excluded from the job position just because of that. And this is just a reflection of a society bias. So this, on the right, you have an example of, if you're interested by this, of an excellent book on the topic that compares the algorithms to weapons, in the sense that they are most of the times hidden and obscure. We cannot access Google algorithms. And they have the potential to destroy and discriminate people, increasing the inequalities and threaten the democracy. Because basically the algorithms have the problem that they can if they are discriminatory, they are going to discriminate consistently and systematically and at a larger scale. And they are going to perpetuate discrimination because there is this conception that the algorithms are fair. If that algorithm is disadvantaging a particular group, it's because that group deserves that. So we need to change the mindset of the users and policymakers and society about this fact. And now I am going to show you some examples because there has been a lot of research on discrimination, discrimination. So for example, in this paper, the authors, the pictures are not very good, sorry. The authors were analyzing the representation of gender in search engines for images. In particular, this is Google. So basically, this is when they did the study in 2015, they were looking for CEO. And basically, for finding the first woman, you have to go here, because this one is Barbie. So basically, they found that the pictures that you can see don't match. Actually, they compare the representation, the actual distributions of gender in the different professions against the distributions that you get when you look for that on Google. And there was an underrepresentation of women. These are the results today, maybe last week, I don't know. And you can see that you have to also see a few males to find the first one, female. But they also look for, not only there was this issue of misrepresentation, of underrepresentation, they also look for how women and men were depicted. And what they found is that there was women were frequently depicted less professionally than men. So for example, this is for looking for, if you look for doctor and men, you will get more or less professional images. If you look for woman and doctor, you will get some underwear, provocative images, and that was not only found not only for that particular profession. They were looking across a wide spectrum of professions, and it was found that there was a significant difference in the way in which women and men were depicted for the professions. So this is regarding pictures, but similar studies have been done regarding online text. So in particular, some others have investigated how Wikipedia represents personalities of women and men. And what they found is that in terms of the numbers, there was no significant misrepresentation, underrepresentation, sorry. But when they did some analysis with natural language processing tools, with artificial intelligence, to analyze the text, they detected that topics that were related to family, gender, relationships, were more frequently mentioned in the women web pages. And also that the negative topics were more frequent in the female pages, while positive topics were more frequent in the male pages. So this is regarding to the content, but you also know that in Wikipedia we have these links that from one page you can move to another if you click. They also analyzed the relationship in the links, and what they found is that the female pages were more likely to link to a male page than the other way around. And the implications of that is that, as you know, the more for search engines and other, like Google, other tools, the more links you receive, the more important the web page is. So basically, that has the effect of moving centrally in the network, the male Wikipedia pages, while the females were at the extremes. So basically, if you look for some particular topic, like scientist, you are more likely to get the male pages, just because they are more central in the network. Well, if we look, this is not very surprising if we look a little bit at the distribution of the writers on Wikipedia, where 90% are male. And we have other examples like gender discrimination in advertising. So for example, another study or paper found that the Google ad service has a tendency to display to men postings that were related to high-paying jobs. Oh, sorry. And this has obviously the potential to even make worse the discrimination, the pay gap. And this is a problem. I have focused here on the gender problem, but it's not even constrained to gender. We have examples with race. So for example, this paper was investigating an algorithm used in the States to decide the risk of reoffending of the different criminals. And basically what they found is that black criminals are more likely to be wrongly matched with higher risk scores, while white criminals have the other effect. They usually are predicted a risk that is lower than the actual risk of reoffending. What are the causes? I'm just going to go very quickly about this. It's more technical. But basically, the algorithms have 3 different steps. One in which we model the problem, one in which we provide the training data, the data from which they are going to learn, and one in which we use the algorithm. In the 3 stages, we can make things difficult. So for example, in the modeling, sometimes what we want to predict is subjective, like the age from a picture, and we have a clear definition of age, and there's no controversy there. But sometimes what we want to predict is subjective. It's like the quality of an employee. And basically, when the programmer is coding what means to be a good employee, the prejudices of the programmer are going to be in that codification. Or in the training data, it is very common to have a data set that reflects the existing prejudices of the decision makers, if we base on historical decisions, or that, for example, underrepresents a particular social group that because of lifestyle and economy is outside of the big data collection process. For example, if you don't have an iPhone, probably you don't have some applications to collect data about you. And this is very scary, especially if we consider that this data is not only used by the industry, also the policymakers are using big data to make decisions, and they are excluding from that big sections of the populations that are vulnerable. Or we might have an overrepresentation. And then when we are using the algorithms, we can also have discrimination, in the sense that if we use an algorithm for a situation in which it was not intended, it is not going to do accurate decisions. So for example, if we train an algorithm for a rural area, it is very likely to perform well in an urban area. But the technology also offers some solutions. So we have solutions related to detection. So there has been research on how to detect discrimination with statistics and metrics that study the correlation between different variables, or also to measure disparate impact, the effect of a particular decision process on a group. Or there is also research on how to prevent discrimination in algorithms. There is research on how we can make the models that we want to learn non-discriminant by using machine learning techniques to learn neat representations of the problem that, for example, mask some protected attributes like the gender, etc. Or in the pre-processing, there are some techniques to deal with unbalanced data sets, to oversampling or do undersampling, etc. We believe that a pure technical solution is not likely to solve the problem. So basically, we have a team formed by computer science, social sciences, ethics, and law experts. And we want to explore this question about how we can address digital discrimination. So basically, we are looking at investigating what are the legal and ethical frameworks for that probably lack information or have some gaps because they were developed before the digital age. And investigate methodologies to get and understand the user expectations, because probably the expectations that we have for a human decision maker are not the same as that we have for an algorithm. And with that, to build a new field of digital discrimination certification. And with this, I will finish. Thank you.